and it wants you to find consumer surplus at point of maximum profit. So in order to do that, you have to find a profit function. In order to do that, you need revenue and cost. Well, you don't have revenue, but you can build it using the demand function. It's a price, multiply the function by X to give you revenue, because price times quantity is revenue. And then you'll have revenue and cost, and you can build a profit function, take its derivative, set it equal to 0. Does that make sense? Awesome, okay. 29. Supply is, yeah, okay. Yeah, this one I'll do on the board, because I didn't do something like this for you guys. So this is 10e to the x over 3. This is supply. Price equals 10e to the x over 3. And find producer surplus when 15 units are sold. So our exit equilibrium is 15 units. Okay. So producer surplus, very quickly, supply goes up, demand goes down, the point where they intersect. Here's producer surplus and here's consumer surplus. Okay, so we're going to integrate from 0 to x sub e. And that'll give us this, that'll give us this. So if we take the revenue at equilibrium, which is x times p, that gives us the box. And then we subtract out the integral under supply from 0 to x sub e, and that gives us producer surplus. So it's PEXE minus the integral from 0 to xe of supply with respect to x. So what are we missing? Price at equilibrium. Great, let's do that. So price at equilibrium equals 10e to the 15 over 3 is 5. What is that number? Anybody?
1484.13.
1484.13?
Yeah.
Awesome. So that's price at equilibrium. So let's do this. Producer surplus is 1484.13 times 15 minus the integral from 0 to 15 of 10e to the 1/3 x with respect to x. Which integral is this? 1, 2, 3, 4? Great. It's not 1.
No, 2.
3.
3.
Why is it 3?
I don't know.
There's an E. Get out your tattoo there, Adam.
I don't have it.
Do it.
I don't have my tattoo.
Get one.
It's that.
Why?
I don't know.
Look at somebody else's.
Where's your tattoo? Where is it?
It's number 3. So my U is 1/3 x. What's my U prime? 1/3. What do I have? What do I want? So what am I going to multiply and divide by? A 3. Right, I'll keep the denominator 1. So do the next phase of this in blue. So now we have 1484.13 times 15 minus 30, and I'll pause so that you guys can go, what the hell is that, Jess? E to the 1/3 x with respect to x from 0 to 15. So I'll let you guys figure out what I did there. Come on, Ryan, you can do it. What did I multiply and divide by?
3. I'm not there yet. I was still copying.
Oh, you were just being snarky.
Yes, I'm very mean as
Seriously, brain dead.
What was the question?
I don't know.
That you asked Ryan?
How did I get this? How did I get this, guys?
Oh, you have 2.
Should be there by now. What did I multiply and divide by?
1/3.
3. I needed the 3 on the denominator to make u prime, didn't I? So what did I pull out? The 10 and the 3 from the numerator, making this a 30 outside. You guys cool with that? Groovy, okay. So now, my integral is, does somebody have this number for me?
22,261.97 cents.
Thank you. Minus 30 e to the 1/3 x, but we're doing this from 0 to 15. And here's where signs will eat you alive, chickens, because you're subtracting this whole mess, not just the first term, the whole thing. Watch. 22,261.97 minus, I'm gonna big bracket this puppy, 30e to the 15/3 minus 30e to the 0. Big bracket.
But you could also do like 1/3 times 15.
Sure, I mean, yeah, but why make it harder on yourself? Yeah.
I just plug it all in the calculator.
So this is totally pluggable, right? This is literally 30e to the 5 minus 30e to the 0. What's e to the 0? 1. What's 30 times 1? Does this term go away? No, it does not. All right. Termites, that's the one I was thinking of.
You've eaten termites?
Yeah, fresh, like right out of the mound. Just
Really?
What?
They taste like mint.
What?
They're minty.
Really?
Anybody else like had termites before? Nobody? Nobody? Okay, I'm weird. All right, we all knew this already.
We're all young in our stages of eating things, so,
Yeah, that's true.
yeah.
I probably would have gagged when I was 23. But now I'm just like, bring it on.
Like little crawling ones?
Like little crawling termites, they're delicious.
Have you seen that one with Bear Grylls and he gets like the big, it's like the inchworm or something? No, the big,
No.
it's like a,
I've eaten a sea snail while I was alive, though.
I'll have to show you after class,
That was
it's pretty
kind of
good.
fun. Yeah, okay.
Yeah,
I'm down for that. Yes, say that again, Amon?
It's 22,261.95.
It's
It's not.
95, not 97?
It's 97. That was the right answer, so somehow I got it. It's around.
3 times 5 gives me a 5, though. How'd you do that, Tyler? I agree with her.
Well, on my calculator,
Oh, it's right.
it's because it's a rounding error at some point, because it's,
Naughty, naughty.
Is that point or what?
Nah,
No?
but Amon gets it.
Someone.
Would you have marked that wrong on the test?
No, I would not have. I would not have, guys. It's 2 pennies, I don't really care. I care more about the process than I do about the answer. You guys know this already. All right, so what is the answer? Who's done the math?
I've done the math, but I don't know if you trust me anymore.
I trust you. What is it?
The correct answer is 17,839.58 cents. And so the error came from the 10e to the 15/3. It's 1484.131591. So if you multiply that by 15, you get 22,261.973 cents.
I see, 97, I see. Got it. Okay, so you're both right. You both get credit. That works. How do you guys feel about this? What was the hardest part? Autumn, you asked for this one. Talk to me.
I thought, yeah, the E, kind of like what the first step would have been,
Okay.
and then what you have and what you want.
Do you have in what you want? Okay. So if what you want involves a denominator, multiply and divide by that denominator. So let's just say that you have something that looks like this, guys. Say that you have 4e to the -3/7 x. So what's your u prime gonna be? Yeah, u prime is gonna be -3/7. So don't waste your time contorting it. If it were me, this is how I would write this. -3 divided by -3 times 7/7 times 4. And then watch what I do. So the rest of it is blah, blah, blah. You understand this, right? We've done this enough times. I need a -3, I need a 7. So what goes out? 28 over -3. So this is how I tackle fractions. You can find your own way. You can multiply by -3/7 over -3/7. You'll still get the same answer, but you'll have a fraction on your denominator. I hate that. I don't think it's clean. But that's my personal preference. You can do it however you want.
So the -7/3 would go on the outside.
28 over -3 would go on the outside. Anything you didn't circle to make you prime. Because your goal is to make you prime, right? So all those elements go into making you prime. The 4 is what you had, and then you're just multiplying by 1 and another 1, which changes nothing, right? Okay. Those are great questions, you guys. Today, it's perfect timing too. Today, we are abandoning integrals.
Oh, yay.
Yes, yes, yay. And we're back to derivatives.
Okay, what if we forgot how to do the
Don't worry, this will refresh you.
Okay, that's good.
Yeah. Except we're throwing a twist into it, because why wouldn't we, right?
Always.
What? You want me to leave out the bottom part? Hi, Wayne.
Hello.
How do you?
How do
You do well? No, I'm just, how are you?
I'm good.
You're good?
Yeah.
I'm crap. Thanks for asking. I'm kidding. No, I am crap today, but it's okay. I'm just teasing you. I really am. I'm just heartbroken. I miss my baby.
That'll be-
Did you bury her in the backyard?
No, she's getting cremated.
Are you gonna make jewelry with her ashes?
No,
Oh, you
I'll
should.
put her in the earth in my tomato plants.
You should make
She'll
her.
feed my tomatoes, and then that way I can eat her.
Spread her ashes.
Ashes amends soil. You guys are so weird. Like, seriously, ash amends soil. Do you guys not plant things anywhere? Jake, you know what I'm talking about. Ash amends soil, doesn't it?
Pig shit all over the farm, and that smelled for 3 days. Fertilize it.
Ash is a great fertilizer. Ash is a wonderful fertilizer. Okay? Don't look at me like that.
I just thought it was.
You put like Miracle Grow in your tomato pot. You don't even know what that's made out of. Mine's made out of cat. Snatch it to your face. Oh, honey. Why do you guys think that's so weird? I think that's a great way to honor your pet. Have it turn its ashes into your food. I think that's a bad thing. It's not. Circle of life. If I were to bury her in the forest, she'd make mushrooms. Somebody's gonna eat those mushrooms, right?
Toss them around.
That's quick. Don't need it. Okay. I figure I can reduce the carbon footprint that was created by burning her by making tomatoes. Yeah, I think it extra to get her back. Yeah,
Take it and then
and
drive
the
it
carbon
back.
footprint of all of that, the carbon footprint of cremation, period. I wanna offset that by making tomatoes.
You could do a tree, that'd be kinda cool.
What?
You could do a tree
I could sprinkle her
so long
ashes at the
and
bottom of a tree.
in like 30 years.
Don't tell me you guys have never done that.
And then you can get another cat that lives in that tree.
Nah. My cats are indoor. I like songbirds. All right. really funky. I'm gonna stand in this corner. Well, it's just new. I'm weird. We're there. Get over it. So this is origin right here. This little thing right here. Okay. This line is going to be my x-axis. This line over here is going to be my y-axis. And this line up here is my z-axis. Welcome to 3D math.
Yay.
All right, it's not as bad as you guys thought. Let me give you a refresher. In 2D, we have x versus y, right? What's our input variable? What's our output variable? Over here, what are our input variables?
X and Y.
And what's our output? Okay, so now we have two variables that go in and one that sticks out. We had one here that went in and one that came out before. Before, we were working with functions that were 2D. The two dimensions were x and y. You can see how the slope in the x direction varies the y output, doesn't it? So change a different x, get a different slope. Change a different x, get a different slope. Change a different x, get a different slope. X, slope, right? So we can say that the slope in the x direction says how much y is going to grow. Over here, we say that we're holding one variable constant and we're going to move the other one. How much did we move x every time, guys?
1.
1. It's the same here. We're moving our variable by 1 and we're holding our other constant variable constant. Hang tight. Let me see if I can describe this. Here's a shape. It's a surface, right? It's a surface. So far, so good? Okay, this is the x direction on the surface. This is the y direction on the surface. And this is z. Everyone cool with that? If I pick a point, let's say this E is a point. It consists of some x, some y, and some z from the bottom. So just like a point in 2D consists of an x and a y, this has an x and a y and a z that defines its space. So far, so good? If I hold x constant, that means I'm not going to move over in any x, I'm going to move over in y. What's that going to do to z? Is it going to go up or down? I have a negative slope. Well, it just rolled off. That's proof positive. I have a negative slope at this point in the y direction. What kind of slope do I have in the x direction?
Stays the same.
It's stable, isn't it? So I can have a single point with two different slopes coming off of it. You guys with me?
Yeah.
Okay. Now if I change this, same point, what's my y direction going to do? What kind of slope do I have?
Negative.
Still negative. What about this one?
Also negative.
Now it's negative as well. So depending on where you are in the surface and the definition of the surface, you'll get two different slopes at that single point. Everyone cool with this? Okay. Why do we hold one and vary the other? Why? Who's a baker in here? Anybody bake? Anybody? Anybody? Nobody? What the hell? It's like gone steadily down over the years. The slope in the baking direction is negative. What's up with you guys? Nobody bakes. Okay, how many of you have made a box cake before? Thank you. You grab eggs, oil, and water, and that's all you need to add to it, right? It's usually like 3 eggs, a half a cup of oil, and a cup of water, usually. It's about the recipe, give or take, right? And all you have to do is beat it, scrape it, drop it in a pan, and bake it 350 for 19 to 25 minutes. What?
Your high altitude.
Altitude. What does altitude do to the baking? Changes it, right? Because things boil at a different time rate. They up here than they do at sea level because of pressure differences, okay? So far, so good.
I don't understand Z.
Hang tight.
personally. Like, is it,
Z's the result. Z's your cake,
so it's like, if
okay?
it's coming out this
Let's
way,
just say the two things you wanna vary are eggs and oil, okay? How do they affect your cake? How would you know if you vary both of them, how they're going to affect the cake?
They're not.
You wouldn't. You would be like, is it the eggs, change in egg recipe, or is it change in oil amount that made this cake delicious or too chewy, or whatever it happens to be, right? So what you would do is you would vary the eggs and hold the oil constant to see how that one change affects your overall cake. Does that make sense?
So is Z like your,
Cake.
I know, but it would be like equals, so like on this side and then.
It's the equivalent of y in 2D. Plug in an x, get out a y. Here you plug in x and y and get out z.
Okay.
We'll get there. So what if we want to talk about farming? What are the things that go into the cost of farming? Just start shouting them out.
Tractor.
Okay, equipment,
Land.
land. Well, what?
Animal care.
Animal care, if you're farming animals, sure. Seeds, right? Labor, somebody's gotta drive the combine, or dragging the horses, or dragging the cattle when it's time. Right, all of these variables go into a successful farm, right? So if you wanna know how buying 500 more head of cattle is going to affect your farm, you would want to hold everything else constant in your model and vary your cow purchases. So far, so good? Okay, that's what I'm talking about here. If you wanna know how one thing affects your overall look, you're gonna vary that one thing and hold everything else constant. So we're gonna work simple, we're gonna work in 3D, but there's actually like 4D, 5D, 10D, where you have multiple variables going into something. Let's just look at the cost of building a toy. Something very simple, right? What are the big things that go into the cost of building a toy?
Design.
Design,
Concrete.
okay, think bigger, think more general.
People to make the toy.
People, labor, and
Materials.
raw materials, okay? Those are the two big things that go into cost, labor and materials. So far, so groovy? So if you wanna see how labor affects your overall cost, you would hold your materials cost constant, vary labor, and see what that does to your overall cost, okay? If you wanna see how materials affects your overall cost, hold your labor cost constant, vary materials, and see how that affects your overall cost. Does it make it go up faster than it would if you increased labor, or does it make it go up a little bit slower? Another way to visualize this is, if I walk, how many feet does it take for me to walk? Oh, come on, guys, how many legs do I have?
2.
2. And if I hold one constant and I vary the other, I get this motion. Is that the same motion as holding this one constant and varying this? Are those the same motions? Is this the same motion as this? No. So you can see how one variable affects the overall look in a different way than the other variable does. So far, so good? Now let's look at some math. This is actually really fun stuff, guys.
What's the title of this?
Partial derivatives.
Oh,
Woohoo!
Is it 13.5?
No, this is 14.2.
Oh, 14.2.
Partial derivatives, 14.2. And next Wednesday is this Wednesday is our final lecture
Yay.
over new materials, you guys. Deep breath, we're almost done. Yeah, Chandler, we're almost done. We have more things to do. We have to review, we have to take exams, we have to study for the final, we have to take the final. But after this week, we're done with new material. It's over. Your semester's essentially over. Okay, guys. Write down that formula. Or equation. And I'm gonna introduce you guys a new symbol. Oh. You know how before we did the derivative of y with respect to x? And this is like a nice, tall, straight D.
Yeah.
Okay. Now we've got something that looks a little different. When we do partials, we use kind of a sad, like a backward 6 or an incomplete 2 or a limp D. Keep it clean, people. It is. There's nice. This is full derivative, this is partial derivative, okay? All right. So now, what was my variable here? I was taking the derivative with respect to x. So what do you think I'm going to be taking the derivative with respect to here? So what's my variable? X. So what's constant? Y. And everything else. If x is your variable, everything else is constant. So I'm going to underline in the same color all of my x's. If a term does not contain an x, it's constant. Yes, Autumn?
So will you just say that again, the dz over dx again?
This is read as the partial of z with respect to x,
Okay.
as opposed to the derivative of y with respect to x.
So all the x's are staying the same?
Nah, this is my variable.
Okay,
So x is my variable. X is variable.
so all the y's are staying
The y's are staying the same. So I've got all of my x's underlined. What's the derivative of x cubed? 3x squared. And the y squared is a coefficient now. It's a constant coefficient. So this first term becomes 3x squared y squared. Okay? Constant coefficients go along for the ride, guys. They're not bad. What's the derivative of 5x? 5 with a y to the 4th going along for the ride. Okay. What's the derivative of negative 10x? Good. What's the derivative of 15? 0. You killed it, killer. It doesn't have an x, right? It's constant. You killed it, killer. What's the derivative of negative 8y?
Or negative 8 what?
I heard it somewhere in the back over there. Is there a variable? So the whole thing is
0?
constant. So what's the derivative of a constant by itself? It'd be nothing. It'd be nothing. There is no x. So it's a constant by itself. You killed the killer.
So
It's
0.
done. What?
So it's the same as like 15 to 0?
Just the same as 50. Now,
I thought we were just changing the,
whoa, hang on. You, then you.
I thought we were
Then
just
you.
changing the x's.
Yeah,
Why did we remove the 8y?
because it's constant. There's no variable attached to it. It's like subtracting
Oh,
15.
okay.
It's constant. You killed a killer. There's no x. You killed it. Autumn, then Blaine.
So we're only taking the derivatives of the sections that have x.
That's right.
And then can you explain why 5x y to the 4th just becomes 5y to the 4th?
So what's the derivative of 5x? 5. And the y to the 4th comes along for the ride. Blaine, you got it. Awesome sauce. Anybody else? Gesundheit. So do you think it'll look the same if I do the partial with respect to y?
Nope.
No, just like me doing the leg thing. One results in a completely different motion from the other, right? Those are the slopes in each direction. So let's try this. The partial of z with respect to y. So now what's my variable? Y is variable. So I'm going to underline all my y's in blue. I'm going to get rid of the x's because we don't care about those anymore. You guys tell me what you think the derivative is, anybody?
2y. With the 3x squared goes along to the right, right? No, yeah.
That's the first term. And I don't care what order you do this. As far as I'm concerned, you could say x cubed times 2y. All the elements are there. Whatever floats your boat, right? I don't care. 3 times 4 is 4 times 3. A times B is B times A. 3A, A3. I don't care.
Wait, why is it 2x to the third?
You tell me. What are we taking the derivative of? So what's the derivative of y squared?
2y.
2y times x cubed.
Oh,
There it is. Next term, 20xy cubed. Next term. Good. Next term. Nothing. Next term. Save. Boy, I can tell you right now, those don't look anything alike, guys. Like nothing alike. And that's how you get different motions in each direction. Okay?
Is this all we're doing?
You get
Sort of.
enough points if I keep it 5x4 to the third?
I don't care. All the elements are there. I mean, it's lazy of you not to make 5 times 4 into 20, but whatever.
More things to make mistakes on.
At this point, I care about the operation of it and not the cleanliness of it, so. Talk to me, guys. Where are you confused? Brenda?
So that 5 is attached to both x and y?
Yeah.
Okay.
Right here?
Yeah.
Yeah, you could just as easily call this 5y to the 4th times x as xy to the 4th times 5 as 5 times xy to the 4th. I mean, like, you can mix it up.
Okay.
Right, so all those elements are multiplied, everything's gonna go along for the ride. Groovy? All right, so let's look at a slightly harder one.
So what's the answer?
Those are the answers. MRM. You like?
E.
Yeah, it's not so bad. The hardest part is determining what your variable is, what your constant is, and what terms go away, what stays, right? So I like to underline it in color. This is magic, guys. Like, for me, my eyeball sees the color, and it goes towards those things. So always start with what you're taking the derivative with respect to. Partial of z with respect to y is my variable, underline y. Partial of z with respect to x is my variable, underline x, okay? How about this one? I want you to find the partial of z with respect to x and the partial of z with respect to y. Pretty please. Don't worry, we'll do it together. There's plenty of time. What's my variable on the first one? Right? So this is a power, isn't it? D out dn. What's the derivative of the outside? 7 jump to the 6th. Nothing changes. Do you touch the junk? No. Strip off that outer layer. Now touch the junk. Great. What's the derivative of the inside with respect to x? So now look up here.
12x squared
Y to the 5th. Beautiful, guys. Good. Yeah. That's not so bad, is it? We've moved on from guinea pigs and termites, haven't we?
And then we find the derivative of that, or is that the answer?
That's the answer.
Really?
Yeah. You've been doing derivatives so long, you've forgotten how easy they are. Look at that. You're done. D out, D in. It's all there. I was waiting for that. This is so easy. Yes. This is why I wait until the end of the semester to throw these at you guys. It's like a long, slow slide into home. Avery.
Are we gonna have to integrate something like that?
No. But remember when I told you that dx at the end was important? This is why, you guys. Because if I do this, what it becomes is this. Do you guys see why? Telling you what to integrate with respect to indicates what your variable is. This isn't, 4x is now constant. So the 4x goes along for the ride and you throw a y on it, because what's the partial of this with respect to y? It's 4x. So if we were to integrate this with respect to y, it would be 4xy. So I told you that this dy or the dx or whatever it is at the end matters because it tells you what your variable is. This is why it matters. We don't go there in this class, but that's why it matters. Does that make sense? All right. So now what's the partial with respect to y?
The same thing.
Yeah, 7 junk 6. What's my junk? To the 6th. Great. What's the derivative of the inside with respect to y? 20x cubed y to the 4th. Oh, you guys, it's so beautiful. Those are so pretty. And we're done. Wes,
Nope, never mind.
sure?
Yeah, I was wondering where the 10 went on that one, but it's 10x. So.
Yep, there's no y, you kill the killer. It's that simple. How do you guys feel? Yeah? Got some happy faces out there? You got some maybe not so happy faces out there? What's the hardest part gonna be for you?
No.
Okay, that's good. How about for the rest of us mere mortals? I expect aces on your stuff from here on out then, Mr. Nothing.
Okay.
Okay.
Is that a bet?
Oh, I'll bet you can't ace my final.
Really?
Yeah.
How much?
I need to like make sure you watch you like a hawk, make sure you don't cheat to get that 50
I'm
bucks
not
or whatever I
cheating,
bet you.
yeah.
I'm not betting you any money. I'm not betting you any money.
Because you know you'll
Oh, honey.
bet. Come on.
I don't bet anymore. I left that life a long time
You
ago.
were just thinking about it and then you changed your mind.
I was considering it, yes. For like that long.
Loser has to buy the other person.
No. No. But I will happily buy you lunch after when you're no longer my student. Come hang out with me and I'll get you coffee or something.
Sushi, all you can eat, let's go.
It depends, where are we going?
I don't know, you pick your pay.
Hey, pick. Damn. Chapter 14.2. I'm going to pull out an application problem because I want you guys to see these. Oh, they're not there. Okay. Production. Suppose a company's production for Q units of its product, so Q is units of product, right, is given by the Cobb-Douglas production function? I don't even know. Douglas. Sure. 70K to the 2/3 times L to the 2/3. I don't know, have any, you guys ever seen this before? Is this an econ or something? Anybody? I don't know. Okay, K is dollars of capital investment. K is dollars invested. So that's capital with an A, capital. And L is labor in hours. Okay. Find Q if K equals, so this is part A. Find Q if K equals $64,000. Oh, it's a $64,000 question. That's hilarious. And L equals 512 hours. That's part A. What comes after part A?
Part B.
A hangover. Okay. Alright, what do you do, guys?
Plug and chug?
Plug and chug. It just wants Q. Did it give you Q? Plug some numbers in, see what happens. Okay?
Yeah.
I'll do that in green. Good times, and you guys can tell me what it is. Q equals 70.
So is it like 7,168,000?
Okay. 7168000.
Yeah.
Anybody? Yeah. But is it in dollars? Excuse me, thank you. What is it in?
Quantity.
Excuse me. Yes, it's in units of product, so is this dollars?
Oh, this,
Unit.
It's units. Good. Good, good, good. So a full sentence interpretation of this might say something like, 512 hours of labor and $64,000 of capital money invested would give us 7,168,000 units produced. And there it is. That wasn't so bad, right? Guess what, guys? RTFQ, not all of these are derivatives. Want to tackle another one? Oh, come on, it'll be so fun. Cost. Ooh. Suppose cost is given by the following function. That's an equal sign. Good God. Do this. 25 plus 2x squared plus 3y squared. Where x is the cost per pound for material and y is the cost per hour for labor. X is cost per pound for material, and y is cost per hour of labor. Okay?
Over, what is that?
Cost per pound, cost per hour. Okay? Find and interpret the partial of c with respect to x when x equals 10 and y equals 15. Because why not? You guys are all doing it. Oh, I love it. Goody.
So we're just plugging in the x equals 10, the x?
What are you doing? Yes. With respect to what? X. Those of you that didn't raise your hands, why? Talk to me. Where'd you go wrong?
I just didn't know what to do with the X and Y.
Plug them in once you're done. If there's nowhere to stick a Y, just leave it alone. Okay? But what you have to know here is X is gonna vary by 1, right? Just like it did in the past when we did 2D stuff. If X goes over 1, what's this gonna do to cost? So if X goes from $10 per pound of materials to $11 per pound of materials, and we hold labor constant at $15 an hour, what does that do to our overall cost? Bend down a little bit, is that better, you guys? Okay. What does that do to overall cost? Blaine, can you see? Wow. Okay.
I can't read the red part.
Okay, it says holding labor at $15 an hour and increasing materials cost from $10 to $11 per pound will raise total cost by $40. Okay? Talk to me, Marco, I heard that.
I don't know what's going on.
Talk to me. What's our variable?
The X,
Great, what's the derivative of that with respect to X?
nothing,
What's the derivative of that with respect to X?
yeah, or X,
What's the derivative of that with respect to X?
nothing, but I thought that you keep X constant since, oh, you keep Y constant when X is on
X
the
is
low.
my variable, yeah. So now I get 4X is my derivative, how come what,
How
Ryan?
did we know that X was the, like, is it just?
I told you in the statement of the problem.
Okay, that's what I was.
Yeah.
Okay.
Yeah.
It'll most likely be given.
It'll be given either explicitly like that or implicitly when it says, find how changing materials
Okay.
affects your overall cost.
Okay.
So that would be the partial with respect to X in this case, because X is materials. Does that make sense? Okay, so knowing what each thing represents is now super duper important, guys. All right?
So the only time we take a derivative is if we have the fraction, like over here, we didn't take the derivative because we
Well-
just had to plug and chug.
Yeah, it's not about having a fraction so much as it's about understanding what it wants. Here, it wants Q. You were given a formula for Q, so you don't have to do anything to it. Over here, it's asking for a partial derivative, but another way to say that is the rate of change, you guys. We know rate of change is derivative. So it says, if it says, find the rate of change of cost if materials is $10 per pound and labor is $15 per hour, and you want to vary labor, for example, what are you going to take the partial with respect with? Why? Does that make sense? Let's do another. Yes, please. I thought so. They're really not that bad. The hardest part is just keeping all the bits straight. Okay? All right. Let's do another one. Out of the text because they're so pretty. Profit. So here's the function that's given to you. Profit of x and y is 10x plus 6.4y plus minus 0.001x squared minus 0.025y squared. X is the number of pounds of kisses. You're making chocolates, by the way. X is pounds of kisses. And Y is pounds of creams. So in this case, we're making and selling two different things. Kisses and creams.
Did you mean to spell creams with a K?
Yeah, I did.
Okay.
It's straight out of the text.
Okay,
We
like
hate
Krispy
these
Kreme.
problems, but yeah, kisses and creams. Apparently, it's a thing in the textbook. Kisses and creams. Yeah, you'll see one of these on your file. Yay. Good times. But, you know, in the interest of keeping it familiar to you, thought I'd expose you to the kisses and creams problem. All right, so we have this function, this profit function, and it wants us to know, what the hell does it want us to know? Profit. Okay, find the partial of P with respect to Y and give the approximate rate of change of profit with respect to the number of pounds if 100 pounds of kisses and 16 pounds of creams are currently being sold. 100 pounds of kisses. So we want the partial of P with respect to Y at X equals 100 and Y equals 16. So before we even do any math, you guys talk to me. What's my variable? Y.
Oh, sorry. Why did I grab Y?
Ah. What stays constant? X. Loverly. Now, how are we gonna vary Y? It's gonna go from what to what? Yeah, 16 to 17, way to go, Kenna. It's the same thing, we're going over by 1 and we wanna see how that affects Y in general, okay, or Z in this case. So here we go. Y is our variable, I'm gonna underline it. Here's my Y's. Great, what's my derivative?
6.4.
Is that right?
Yeah.
So is it like dp over dy equals? So when you say equals, like what is the?
I'm saying the partial of P with respect to Y when X and Y equal these numbers.
So all of that.
Here's the,
equals.
yeah, here's the partial, and now I'm gonna plug in 116, if I can. Can I stick the 100 anywhere?
No.
No, so what does that tell you? That,
Why?
that the selling of kisses has absolutely nothing to do with the profit off of extra creams, does it?
Yes.
True.
That's what it tells you. Because your profit isn't affected by, if you're looking at profit of creams or how the profit of creams affects your overall profit, kisses aren't gonna be in it, guys. Okay, they're not together. I know, it's crazy, I'm sorry. So now we just plug and chug. So now I'm gonna take these numbers and I'm gonna plug them in. So equals 6.4 minus 0.05 times 16. I don't even know what that is. How much? 5.6 total? This equals 5.6 or $5.60. So how do we interpret this?
That's how much it's gonna change when we increase the pound of creams.
Yes, holding kisses to 100 pounds and adding a 17th pound, right? It's specifically a 17th pound of creams will increase our profit by $5.60. How do you guys feel?
Great.
Better a little bit? So you like partials? Yes?
Can you have a handout to give us
Oh, hell yeah.
with an
Well, they
example
were asked,
Yeah, with examples.
for us to do right now?
Yes, for you to do right now. Yes, moving on.
Yes.
Okay.
so will there ever be a problem where we'll have to do both, like with respect to X and Y?
Possibly, yes.
Okay,
Yeah.
and then we would just take the derivative of Y, plug in the Y value, take the derivative of X, and then plug in the X value.
Mhm.
Easy.
That's it.
Okay.
Yeah. Marco?
If there was to be an X and a Y in the second, or in the derivative
Mhm.
that we took, would you just plug them both in and then that?
Oh, yeah, you would still be plugging in 100 for X and 16 for Y. But what that tells me is that the profitability of each one is dependent upon the other. So, does that make sense?
Mhm.
Because if we're looking at how holding kisses constant and varying creams affects your overall profit, and kisses are still in the equation, that means their profit is interdependent. Okay? So in that case, you could think of it as like market share, right? People buy so many pounds of candy. If you move the supply of kisses to be something bigger, or the supply of creams to be something bigger, people will buy appropriate amounts, right? It's not gonna change their demand unless you lower the price to go along with it. Does that make sense? Yeah, okay. Which would overall affect your profit as well. But we keep it simple in this class. So here's your handout. Smart ass. I love you guys. I seriously have had so much fun with this semester.
With
You guys
us.
have been a lot, yeah, with you guys. This class specifically has been so much
Which
fun
is your
for me.
favorite classes, isn't it?
I'd say so, yeah. Yeah. And it's not that I don't love my 8 a.m. business
They're just
calc or
boring.
my stats or my math for liberal arts, but you guys are sassy. You ask questions, it makes me happy. 2, 4, 6, shit, 2, 4, 2, 4, 6, 8, 9, oh my god. 2, 4,
It's a good thing that class is a project.
what?
It's a good thing that class is a project.